What's
All right, so I want to dovetail in the conversation we were just having, because I think just listening in the conversation, I think the first thing that would be going through my mind is, what do you actually do with this? And I think your question, Mark, was actually key. Where are we winning? And I think the best way to describe it is, we're winning in places where people have found that the system and the existing technologies are breaking and they're failing. And sometimes it's actually organizational. And we're going to walk through 3 different places where this happened. And I'm actually going to tell you a story. We'll go back to this, because this gives you an idea of how we see the world. And we're going to cover specifically the critical IT case. This is not a fun story to tell, because we're going to tell you about literally the worst day of somebody's career and what they learned about something that they never expected to happen. So if we talk about critical IT, the reason we think sometimes you need a different architectural approach is that we fundamentally believe, I think if you sum up the one thing we believe more than anything else, we believe that some apps are different than others. You look at what the industry's been telling us for the last 10 years, it's been about consolidation, it's been about virtualization, how do you make your data centers more consolidated and fluid, and how do you make everything look the same? And we learned something about that. Some apps really are different. If you sum up every one of the use cases that we cover that we're actually going to go through right now, we're going to talk about why we think some of these apps are different and why we think the existing systems aren't serving those really well. So I skipped the intro, by the way. My name is Dan. I run technical marketing here. We'll get into some gory details, but this is really the point where we want to talk about how people are using this stuff. What I'm going to tell you is a real story, by the way. This actually happened. We're going to talk about a really bad day. So before I show you the next slide, we'll set this up a little bit. What have we all been taught? My background is networking. I'm a network guy. I've been in networking for 20 years. I've worked at the various networking companies. And every time I got really gory into various architectures, especially working in security and networking, you're always thinking about, how do you control something really simple? How many of us have had a discussion about blast radius? You want to think about, how do you build a survivable infrastructure? And every single vendor has talked to you about this. And we usually think about this in terms of boxes, but what it's really highlighting is sometimes you have to look at how things fit together to figure out how they can fall apart. And this is what we learned. So we were at a customer site. We were actually working with them to secure their Active Directory. We've built in a bunch of functionality into our platform to specifically protect Active Directory, just because it's actually a pretty tough application to be able to protect. And we'll get into that as part of the demo, but while we were there showing them how to protect Active Directory, something happened. And it wasn't clear what it was. It was a Tuesday, and in the middle of our session with them, suddenly everything started going away. Literally everything. And I'm sure, I see one person nodding, Howard, I'm sure you probably have a guess as to what this was. Suddenly you couldn't log in anywhere. Okay, that was the first symptom, that's not good. Well, but it's worse than that. So what do you do when you can't log in? Well, you try to go find some of your key systems and log into those. All right, so maybe you want to shell into your DNS server. How do you get there? Do you remember what the IP address was? Because guess what? DNS wasn't working either. Okay, well, what would you do next? Think about literally every tool that you would use to figure out what's going on. And at this point, I know at least one of us has guessed what the exact problem was. But imagine if every tool you would normally expect to use to get your business back up and running. And by the way, once they realized they couldn't log in, they also started realizing that the actual licensing servers, the line of business stuff, the stuff that was making them money per minute was also not working either. That also went down. So what would you do? You have so many tools that you can get access to, but they've all been intertwined in a way that we weren't expecting. This probably looks familiar to some people, but this was not a happy thing for them to see. The quote that I got, I wasn't on site, but my colleague was there. The quote was literally, we walked in the data center, on every console, it was a sea of red. They were highly virtualized. They had done all the right stuff. They had done all the right architectures. And in the end, this is all they saw. The worst place to see this, by the way, is on the console of your vCenter server. because that makes it very difficult to go in and start to remediate other problems. So imagine what this looks like. You really start to realize what organizational dependencies you have. And if we take a step back, think about what we were talking about earlier in terms of security. Why are the bad guys winning? It's not because people are dumb or doing the wrong things. The problem is the goalposts have moved. The architectures and the organizations that we put together back in 2007 are not valid anymore. Things have changed. The attackers have changed. The goalposts have changed. And in this case, these are actual photos taken. They sent everybody home. Multi-thousand person company, literally everybody went home except for IT, and people were working 24/7. They were not allowed to go home, only went home on shifts. They brought in chair massages, everything. And you can imagine what this is like. And in the middle of this, the other thing they realized is when it gets this bad, sometimes people had enough. Their chief network architect was sitting there keying in ACLs for 8 hours without a break, and eventually got up and said, a word I'm not going to say here, and left.
Well, he also said this, didn't he?
Yes. What would you even do? So imagine this happened. Let's not even talk about how we got here, but let's now understand.
Yeah, I'm having difficulty with how we got there.
How did we get there? Well, we'll do a little bit of this. So there's actually a post-mortem in here. We'll talk about that.
Okay.
So imagine you're in this situation. So imagine you're this person. Imagine you're now the CIO.
Been there,
left
done
of
that.
The IT org. The first thing you're thinking about is how do I get the business up? And we're going to figure out how this happened after that, right? We're going to clean up the mess first. We happen to be there. And when we were there, one of the things that we looked at was what are the root causes of not being able to build anything? Do you start by rebuilding the services that are actually line of business, like licensing servers, actual code repos? No. There's no point. Because guess what? The environment is actually toxic. If you bring up a new VM, it's going to actually be infected in seconds before you apply the patches. Like, that's how bad this environment could be. So what do you actually do? How do you actually start to rebuild some of the critical services? And what they learned is it doesn't matter what anything else is doing if certain services aren't working in the infrastructure. That was actually the first lesson. So we actually worked with them and formulated a plan to literally bring up the baseline services. Think of the things that are plumbing that you never think of, that your network and your entire enterprise won't work without. Active Directory, what's your source of identity? Oh, their web single sign-on went down too. That was fun. DNS. Everything relies on DNS. You got to fix that. IP address management, and then things like vCenter. This is literally where you start. And then you have to look at another problem of how do you rebuild this stuff and don't allow it to get infected. So now think about the tools that you have to do that. How would you actually do this when you don't even have any portion of your network that isn't toxic? This is sort of the problem space. And if you look at how you would solve this problem today, this is kind of gory.
Well, you build a sandbox and firewall it off from the world and...
Exactly. You'd almost want to be able to establish a safe, secure place.
Oh, yeah, no.
Actually build stuff.
If this happened the day your gear was on site, I'm starting to get suspicious of you guys. Because
great sales tactic.
Because
How was the ransomware delivered?
that is as serendipitous as that somebody tweeted a GIF of a golden retriever puppy in a cow suit the day after I made a pets and cattle joke.
It wasn't that fortuitous. We'd actually been working with the company for about 2 years at that point, and they had been stymied by budgetary issues for a long time.
Oh, this will open up the wallet, though.
Yeah. We'll leave it at that.
I've been in situations like this where it's like, no, there's no money. No, there's no money. Oh, how much do you need?
Yep.
I'm going to leave it at that.
Yeah, and what we learned was a couple things, because assumptions had changed. And one of the things we learned was a lot of the assumptions for the threats they had built their architecture around were really rooted in 10, 15 years ago. What happened new in a worm like this? It started using the infrastructure itself against you. It included Mimikatz. What was the thing that really did the damage? As soon as this worm got in, all it had to do was find that one laptop where a domain admin was logged on, and now it's got carte blanche around the entire domain. That's how this spread. And it's the little stuff that you don't think about that is now starting to be used against you. These are the things that we actually
started in tech
realize.
support in an international location, then they had way too few domains.
So this is really what we learned is at some point you have, everybody's got a DR plan. Usually it's a big D and a little R. And we learned that in many
Backups
cases you
were-
don't really know until something happens.
Backups were compromised too.
Yeah.
So they were entirely on the Malamar model of security. The chocolate shell had to protect the whole marshmallow.
Was not a happy place that day.
Oh no.
So how many backup plans really think about how you recover AD and DNS? That actually turned out to be the most important thing.
There are two articles
Yeah, all
in
of
the
them.
Microsoft knowledge base about restoring Active Directory that are bugs I have found myself. So, yeah.
And to be fair, this is actually what things like Red Forest are all about. I mean, this is why we've seen some of these architectures updated. But in the end, what did we learn? How do we start to actually architect in resiliency? So this is kind of a long story to tell a pretty simple point, which is there's certain parts in the enterprise where it is actually worth thinking differently about what the infrastructure looks like. And one of the other things that we realized is actually an organizational thing. You asked a great question earlier. Why do we win? So we have a large number of customers that use us to actually protect Active Directory globally. And it's not because of any one security feature. In fact, it's actually kind of ironic why it's so important for AD owners to work with us. We actually solve an organizational problem even more than we solve a security problem. If you own AD, you own the most sensitive application in the entire company. You own basically identity. You have all the risk, and organizationally, you have almost none of the control. You have to rely on multiple other groups to secure it, to encrypt the disks, provide the right security controls, manage the OS, all these things. You're relying on
and
other
unlike the
groups.
guy who runs the ERP, you don't generate revenue, so you have no budget to do those things.
Exactly. Let's actually take a look at what something like AD looks like on here. Now imagine this is less about the infrastructure and a lot of the technical details that we looked at, and more about put yourself in the mind of the AD owner. You own Active Directory, you need to protect it. How do you actually do that? Well, one of the things that's often a challenge is because you're relying on so many other groups, the problem is making sure that each one of those security controls that you know needs to be there is usually the hardest part. So in this case, how do we allow somebody to actually run critical infrastructure like AD or DNS and actually protect it and do that correctly? The first thing you'd want to do is allow somebody to deploy and own Active Directory in a way that they don't have to be a virtualization expert. AD people know AD really well, but they don't necessarily have to know virtualization. In this case, generally, you don't generally have to do too many things custom in terms of that. So in this case, we make virtualization very simple. It's actually just simple VM resources that you actually hand out for virtualization. What you're really trying to do, though, is protect it. So when you deploy a VM in the system, Will touched a little bit on this, but what we're really doing is we're not really just running a VM. The point of what SkySecure does is we're effectively building a secure room that each virtual machine lives in. And that's really the goal. How do you build a secure room where you can control everything that goes into and out of the system, but how do you do that without making it extremely complicated? One of the things that happens under the covers is we build a microsegmented network around every single VM. It's actually a private network. But to make this work, you need people who own AD to be able to do this without making them networking or virtualization experts. In fact, this is no harder than actually just mapping to a VLAN. In fact, we make all of that complexity underneath the covers go away. In fact, it's just a simple private network that gets mapped to this VLAN, and we can automatically detect who's attached to it. So part of this is providing this level of control without making people have to deal with the complexity. Now, the bigger problem that we found is it's interdependencies between groups where this gets really hard. If you look at how do you, for instance, deploy a domain controller and then secure it and lock it down, so you can maybe allow things like Windows updates, but prevent things like malicious code or a C2 channel or an exfil channel from happening on that domain controller. Well, maybe you want to wrap some policy around it. But first thing you'll notice is for us, the configuration is more about the room that the VM lives in than on the VM itself. So think about how many places you would normally have to touch in order to lock down AD. When you deploy AD, you may own the application, you may even own the actual OS itself. But who do you go to actually ensure that there's disk encryption there? That's pretty key, especially in a remote location. Why can't that be part of the platform? Why can't you be able to do that without having to deal with key management? Likewise, if you're going to start protecting Active Directory, you need to allow AD to work. Now, the last time I had to do this on a firewall, it was pretty gory. You go to a page from Microsoft, it's pretty sizable. They give you a list of all the protocols, and half of them are port hopping protocols. It's pretty gory. But in the end, if you're the domain owner, what you really want is to click a button that says, I'm a domain controller. Only allow the authorized AD protocols. Make AD work, but whitelist everything else. So in fact, here, it's a couple clicks. The only thing you feed in is actually the domain name. And actually that matters, because the domain name is actually how we build the policy. Under the covers, one of the things you're getting from us is also best practice. By just creating this policy, you've automatically built all those policies to make AD work. In fact, that one policy is actually part of the SkySecure system. So in the end, you've actually locked down your domain controller. So all it's able to do right now, in fact, you can probably audit this config right now, is it's deny all. We allow Active Directory to work. And by the way, you also need things like updates to work. Well, an update is just a web connection, right?
Well, it depends on whether you're on WSUS.
Yep. Well, that's just a web connection to a private port, right?
Yeah, but
so in this case, how do you allow WSUS, or how do you even allow Windows Update? Think about a remote case. That's even worse. One of the really, really unpleasant things to look at is how do you whitelist Windows Update? We'll talk a little bit more about this in the cloud section, but it's a list of URLs. You literally can't build that in a firewall. You have to open yourself up to the entire internet. One of the things we've also built in is the ability to actually build policy around that. So another click, we've automatically created Windows Update policies. You can put your WSUS server or SCOM server in there directly. Yeah. And now, in a couple clicks, your AD owners have deployed AD in a secure place.
See, the sad part is Microsoft should have done this and made a Windows firewall rule that says, this is domain controller, let it do domain controller things.
Mm-hmm.
So congratulations, you guys are following a long history of doing things Microsoft should have done but didn't, and therefore making a fortune.
Yeah. Well, but on top of that, would you actually trust Microsoft to do it? Because here's the other problem.
Well, that's a completely different story.
That's another question. You've got a switch, right? Mm-hmm. So we're talking about how easy this is for an AD admin to get AD up and running, and you give them a switch that lets them do Windows updates. Are organizations just taking their AD server and going out to Windows to do updates on it, or are we?
You probably wouldn't. This is a worst case. So imagine you have a remote site where maybe you do need to reach out directly. Windows Update itself is actually a particularly hard thing to lock down. Yeah. So in most of our production customers, instead of using this, they would build a policy that only goes to their WSUS server.
Yep.
But in the end, what's also happening by creating this policy is we've also done something else. We've actually created a proxy around the VM that intercepts all outbound web browsing. What this also does, once you've built this policy, is it also stops the number one vector for infection, which is a drive-by download.
So from a trust verify perspective, so I have my FDA auditors coming in and saying, okay, these other systems that are not on this platform, I understand this appliance model. Show me that your appliance is in your security policy within compliance of your security policy. What reporting do I have available to prove that?
That is a great question.
Thank you for asking the question, because that's actually the next piece.
We specialize in leading questions.
Yes, we do.
So what do you have to prove? You have to prove a few things. Number one, is it covered by policy? So first, I can click a button, and this will actually output a list of all the firewall rules. We happen to have a couple other things here on the same VM compartment, but this actually will give you an output of all the firewall rules. And by the way, this applies just to this one VM. You're not pulling a needle out of the haystack from some upstream firewall. This covers 100% of the surface of that one VM. Now that's great, but what I would also want to know is, sure, you can have a policy, but is it correct and has it been in place? One of the other things that Will touched on is it's not as simple as just having a policy. One of the things that we give you in the cloud management service is also an audit trail. Everything that happens administratively becomes part of a permanent audit trail. And in
So
fact,
does that go as far as show me all my domain controllers and whether they've ever been exposed beyond the default policy?
I can do one better than that. I can tell you who has changed every policy, and in fact, I can go yell at my coworker here who happens to have changed it.
That comes second. The first is something's wrong. 6 of my domain controllers have been exposed to the world.
Yes.
Kill them, and then we'll go figure out.
Well, let's actually ask the more uncomfortable
You know.
question. Let's say somebody did open the policy. How do you know what it opened, and how do you know what the effect
first you
was?
kill, and then you assign blame.
Right.
Yes.
Yeah.
Yes.
Okay.
Yeah.
Yeah.
And to Rob's point, one of the other reasons why this is attractive, especially if you own AD, is let's say you see something weird. What's the first thing you want to do? How do you hit the lockdown button? If you have something going wrong, how do you actually have the ability to hit that button, maybe find a remote domain controller that hasn't been hit with a worm, hit a full lockdown, cut it off from the outside world, preserve a copy of your DIT and your entire domain structure in that box where you have the power to lock it down without having to call a whole bunch of other people to do it.
Question for you though, you said when you see something weird, are you assuming some kind of automatic monitoring system, or are you assuming somebody, like a person, is noticing something weird?
There's a couple, so that's actually the other key point is, first of all, how do we give you first visibility and data, and then how do we give you useful information on top of that? So the first thing we've done is we actually give you visibility into everything that it does. And then we have some reporting functions that live on top of that. In general, we're not trying to be the product that will find every potential anomalous behavior. What we are very good at, though, is gathering very good, clean, contextual data about what's happening. So
Clean data's half your problem.
yeah. Exactly. So what you're looking at here is, imagine if you had the ability to have full one-to-one sampling for every conversation a VM ever had. And now you can contextualize it. So now imagine that instead of going to a NetFlow probe to figure out what conversation might have come from your domain controller, now you can actually see every conversation that it had. That's what we've built into the system, and we can report directly on that. In fact, that's exactly what you're looking at here. I can zoom in on some of this, and you can start to see that we can understand individual protocols, individual addresses that it talks to, and more importantly, we can tell you whether the traffic was actually allowed or blocked. So as we're going back to an auditor, let's say a policy was opened. This is what's actually been happening over the past, the past hour. I can go back in time. Imagine I go back, I don't know, let's pick a date. Pick a date, or say maybe June 6th through June 7th, 2016. It was a simpler time then. And with a couple clicks of a button, that's every conversation that domain controller had back on June 6th, 2016. So as you're talking to an auditor, it's not only a question of being able to prove what was the policy coverage at a certain time. We can also tell you what every conversation was that happened, who it talked to, and what policy allowed traffic through.
Can I see something like this for a group of machines? Maybe like to identify like a common command and control server that they're all connecting to or something like that.
Are you talking about a defined group or this is all DNS traffic to identify the groups, or all DHCP traffic? A self-defined group or a defined group?
I think maybe what you're getting at is one-to-many in the sense that this machine was infected and, it talked to 1,000 other machines that day.
Yeah.
We have a lot of that. In fact, what you're looking at here is I had actually filtered it down to just that one system. But what you can see is you can quickly see how much data there is.
Yeah.
And what this is really designed to do is how do you take this volume of data and understand exactly what you're seeing and then act on it. So Nils is hovering over, pointing out that I'm way over time for this section. But I think
We started early.
And just to close this out, though, hopefully this gives you an idea. We talked a little bit about sort of why things like this happen.
Okay, I love it. It reminds me of the last network project I did at a college, and the thing about colleges is the dorms are less trusted than the public internet.
I'm glad I went to college before NetFlow existed. Let's just leave it at that.
How many applications do you have this level of detail for? AD's great, but
All of them.
This isn't application specific. This is actually flow specific.
no. But you have
switch,
you have
switch.
the
So using this as an
400
appliance.
rule firewall set for AD.
Right.
That I just have to go. It's AD. I don't have to define 400 firewall
Yeah.
rules.
The template.
How many applications do you have those templates for?
So we started off with the ones that generally people got wrong first. And we started focusing on things like AD, because one of the things we realized is this is less about the policy and more about how you allow self-service for people. So AD was a big problem. Things like Windows Update, things like Active Directory protocols was a big one. The next thing we realized is that some of these are important. So we actually have the ability of building in templates for these things. And before the next demo, we'll fix the screen so it's a little easier to see. But as you go into individual protocols, what we also realize is it's equally important to be able to build your own. So the other thing we have is the ability to start to build internal rule sets. And this is really how you start to work with a security team. So we can either create sort of a template when you deploy it where it automatically inherits rules, or you can also have this idea of a rule set. And we built a really simple one here. We have a lot of Linux instances in our demo environment. So we've built a rule set that allows it to do the baseline stuff. It allows us to go to an APT cache, which is local. It allows it to go to NTP services on the internet so that you can just get the baseline things working for Linux. And this way, you just subscribe to this as a best practice policy. So the bigger thing we're trying to solve is also organizational. How do you allow people to deploy VMs? How do you make sure those VMs have the right security policy? How do you make sure that they can subscribe to the right security policy as defined by the security team? And by giving people a place to put it where the security is built around the VM, now you give the security team the ability to audit everything that's going on. And you'll find that this is kind of a common theme in a lot of the use cases that we're going through.
Do you do anything where if you can create your own, it would be creating your own entitlement group, right? Is what you would create. So do you do anything where you can create an entitlement group for an app that we're deploying and then publish that out where you guys can vet it and others can have it?
Oh, sharing.
Yeah.
Yeah,
We don't have sharing yet.
Entitlement store.
That's a good idea,
Yeah.
though. We haven't done that yet
Copyright,
because it
2017.
mostly we're not there yet. But yeah, we've talked about it. But it's a good idea.
Yep.
So since you mentioned that you're also trying to solve some organizational problems, this is more of a philosophical question. Is the inherent and secure by default nature of what you've built, is there something about that that's going to protect me from the people in my organization more so than what we already have? Because I think we all agree, like
Malicious
that's
insider.
the real vulnerability, right?
Yeah,
Is
malicious
me.
insiders.
And so because it's built to be secure everywhere by default, is that better in that sense
Yeah.
than what I'm working with today?
So let me give you some insight into some of what Will was going through in the architecture talk. What's different about how we approach security is we actually made a very different assumption about security. We actually assume, even if you're running your critical AD services inside of us, we actually assume that every VM in the system is compromised. We built the system to protect itself from the VMs. We'll build the system to protect VMs from each other. And this is why we don't trust OS vendors or OS policy to actually protect systems. We wrap it around the VM. And we do this in a way that it can't be bypassed, and you have logging and you have visibility that can't be changed. And to your point, that's exactly what this is for. It's why we build an immutable audit trail. It's why everything that we saw in that log, you can't change it, you can't delete it, we can't change it. This is part of the immutable audit trail for each one of the VMs, cradle to grave.
But I want an immutable audit trail for everything everybody else does, but not for what I do.
All right, so I'm going to stop there just because we've gone critically over time, but I do want to also leave some time for two other things. I think you'll see that this critical infrastructure answers the question that you had earlier, Mark, of literally where do you use this and where do you start? And this is really designed to fill in the gaps where the existing architecture is just creating organizational problems. I think the other thing that we'll dive into now is where's the other place where it's difficult to get this level of control?